Hello, welcome to the data channel, and you are watching a data modeling masterclass series. And as part of this video, we will discuss what is the difference between conceptual model, logical model, and physical data model when we are discussing from the data modeling perspective. So what exactly these concept means and how they are different, right? And most often, so these are so there is a thin line between all of these kind of models, and people often have some sort of confusions. So if you want to learn more about this, so we will explain with examples and with some detailed points we will bring up in this video. And before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So data modeling at different level of abstraction. So that means here whatever we are talking, that is starting from conceptual model, logical model, and physical model, right? So these are nothing but at a different level of abstraction. That means so whatever you see in the like a conceptual model, right? So that will not it will be very high abstract level, right? And whatever you see in a physical model, it is very low abstracted, right? That means it is having more details. So that how exactly that what are the details that are captured? So that is what we will discuss in this video, right? So what are the different data model? What are the different data modeling perspective, right? So what are the different level of abstraction? If you see, first is conceptual data model, which is also called as CDM, and the second one is logical data model, which is LDM, and the third one is physical data model, which is PDM. So conceptual model focus on understanding the business requirement and defining high level concepts and relationship between them. So here it is more of a converting the business requirements to kind of a document, so which business understands, or which the stakeholders from the business, like most of the stakeholders understands, right? So this is not a technical at all. So this is completely a business documentation where you capture the requirement and derive some of the relationship between maybe features, what are the modules you will be working on. So it is just a paper and pen, you just take and you just derive the relationship between them, and so that will be aligned or agreed with the business, right? And when it comes to the logical data model, so this will translate the conceptual data model, right, into more detailed and structured representation. So compared to physical conceptual model, so logical model will have more detailed and structured representation, focusing on how data will be organized and stored. So here is where we start thinking about the data. So here in the first conceptual data model, so here we are not thinking much about the data. If you really see, here we are thinking about the requirements and how to capture those requirements. But when it comes to logical data model, we already started thinking about the data and how to store and organize the data. So that's the difference, right? And finally, when we talk about the physical data model, here is where we actually think translating the logical data model into more specific, structured, and that can be implemented in the particular database. You consider any database, right? SQL, Oracle, NoSQL, any kind of databases. So here is where we need to define a physical data model from the architecture perspective, where we define how exactly the data will be stored in the database. So we need to have a plan, right? So that is where it is physical, right? Because physical is the data is getting stored in the database. So here it is just a plan on the page, right? Here it is just there is no thinking about the data. So here we started thinking about data, but here is where we are thinking about the data and physical representation, or the physical storage of the storage and organization of the data, so that we plan in this particular this thing. And if you clearly see the sequence, right? So always the conceptual model will be first, right? So we need to have a conceptual model first, and later we can have a logical model, and the third one is physical model. So yeah, it should always be a sequential, right? So it should be like first you need to have a conceptual model, then logical model, and then you can have a physical model. So and you might ask like, okay, is logical model compulsory? Need not be, right? Because if the requirement is not too complicated, so you can avoid the logical data model, and you can just convert the conceptual data model into physical data model. So from 1 to 3 you can directly jump, right? So it depends actually, but physical data model is a must because that is where you are actually storing the data, right? So this is the must have a data model. But conceptual model is also, I would say, it's must have. If you take any enterprise projects, it is a must have where you capture these details and then you can convert those to a physical data model, right? So let's move on and and see, let's start seeing from the detailed perspective. So the first one is conceptual data model, CDM. So what exactly it means, right? So it is a highest level of abstraction and representation of the key concept and relationship within the organization domain. So you might be working in any domain, maybe healthcare, retail, right? Maybe energy, right? Maybe management information system, maybe finance, marketing, sales, whatever domain you are working or the project is, right? Or the organization is. So that, and what are the entities? What are the tables? What are the relationships? So that logically you need to have that representation here in the conceptual data model, right? And it serves as a foundation for understanding the business requirements and defining the scope of a database system without getting into the specific implementation detail. See, this is usually this particular job, that is a conceptual data model. So it is not usually done by the data engineers or the database administrators or the developers. So it is mostly done by the like architects or sometimes a business analyst. So if you are a business analyst, so here is where you need to understand the business and help architect to come up with the conceptual data model. So because as a business analyst, you know the domain or you know the um, particular project requirements and the business dynamics of it. So you can help the architects or you can build a conceptual data model here. So here that serves as a understanding the business requirements. So this is key, right? So you're understanding the business requirements here and defining the scope of the database system without getting into specific implementation. So here we are not at all thinking about implementation details, right? And CDM are typically created during the early stages of the database system to capture the essential entities and relationships. That means tables and how they are related to each other and how they are relevant to business. So, right? Because here the conceptual data model is about the business, right? So you are understanding the requirement business. This is completely a business point of view. So here there is no, you are not at all thinking about the implementation or any such aspects. So you need to design this conceptual data model that business also understands, right, and agrees. So that is where once you do the conceptual data model, you need to agree with the business that okay, this is what we have developed. Can you please validate and give a sign off, or can you check and see if we are missing anything, right? So that's about the conceptual data model. And if you go in detail, so first thing is understanding the business requirements when you come to about CDM, right? So the primary goal of creating a conceptual data model is to understand the business domain and its requirement. So this involves identifying the main entities like objects or concepts and the relationship between them. Like suppose you are creating a ERP tool, enterprise resource management tool. So there, what are the different entities? Maybe invoice, purchase order, right? So what are the entities you can think of, like customers and how they are related? So how customer is related to invoice, how invoice is related to business unit. So all those things like a level of understanding you need to be about the business unit to have, right? And then comes abstraction. So abstraction is a CDM operates at a high level of abstraction, focusing on the essential entities and their relationship without considering the implementation. So that we have already seen, such as maybe what is the data type of the particular column, right? You're not worrying about that. Or what is the storage structure, how the table to be stored, like whether it is stored in the CSV format, tabular format, whatnot, right? SQL, no SQL. So that you are not at all thinking here, okay, in this CDM. And the next one is entity relationship modeling. So this is CDMs are often represented using entity relationship diagrams, that is ERDs. Entities are depicted as rectangles, right? And the relationships are represented as the connecting lines between them. So that is a ER diagram, famously called as a ER diagram, right? So here is a table, and you have a tables and how the tables are related to each other. So tables are nothing but entities here, and relationship is like how the each tables are related to each other. And key elements, if you see here, entities, as we know, it's the main, these are the main objects, which are also the tables or the concepts in the domain. Each entity represents a group or group of similar data instances. For example, if you take university database or domain, entity might be include student, course, instructor, department, etc. And if you talk about attributes, attributes describes the property or characteristics of the entities, right? Of the entities, and they provide additional details about the entities. For instance, attribute of students entity might include so student can have student ID, name, date of birth, right, etc., right? And what about relationship? Relationship is how the entities are related to each other. Suppose these are entities, right? And each entity having its own attributes. Okay, how student entity, and this is a department entity, how student is related to department. So this is a relationship. So student and department are entities, right? And these are the attributes like student ID, name, whatever the department here, department ID, department name, and also these are attributes. And so how student is related to department? So student belongs to department, right? Right. And student, like maybe you can have one more here where we connect to this one. So where you can have a marks table, right? So student obtains marks. So this is a relationship. So here student belongs to department. Here student obtains marks. So that is a relationship. What exactly the relationship? That is what we are calling relationship here. So next is entities. Um, so like let's take example right here, the conceptual data model, a CDM example. So we are taking database management system. So here entity might be like student, where represents individual student enrolled in a university. So course might be like represents the course offered by the university. Instructor represents the faculty members who teaches the course. Department is represents academic departments within the university. So and attributes, like, so we, I'll not go in detail about all the attributes, but you can just pause and look at these attributes, right? Student is having their own attributes and course instruction department is having their own attributes. But the point here to is notice all the tables is having the IDs, which is usually the primary keys to uniquely represent the each rows in the entity. So next, the continuing, right? So here when you see how the exactly the conceptual model looks like in the university management system database system, right? So you have a student database, student table that we already say, student, course, instructor, and department, right? So how these are related to each other, right? So as you can see, we have a student and he enrolls to the course. That means it describes the relationship between the student and the course entity, indicating that a student can enroll in multiple courses and a course can have multiple student enrolled, right? This is a many to many relationship actually, M is to M, right? And the next one is so course is taught by instructor, right? Represents the relationship between the instructor and the course entity here, signifying that instructor teaches one or more course and the course is taught by one instructor. So here it's one to many, one to M, right? And the next one is the instructor belongs to our department, right? So here this shows like belongs to relationship, right? So this is nothing but shows the association between the instructor and the department, indicating that instructor belongs to one department and a department can have multiple instructor associated with it, right? So these are all the relationships that we see, right? So this is very important to understand. So this is nothing but this is identified in the CDM. What is the relationship, whether it is enrolls, whether it's taught by, belongs to, has, right? Many things might when you're talking about the real-time scenarios, there might be n number of such like you can derive in a number of relationships, right? So similar to that, yeah. So moving on, the next is we have a logical data model, right? So logical data model as part of the data modeling again. So is a structured representation of data requirement, business rules, and relationship based on the conceptual data model. See here, the important again important point is here you started understanding the business rules also. That means we are getting trying to get the more refined requirements here, right? In the previous conceptual model we were not interested in more refined requirements. So now when you are designing the logical data model, so we need to dig through more about the requirements and go to business and ask more detailed requirements or more detailed specifications, right? And also we need to derive the relationship based on the conceptual data model. That is a previous stage, right? And so here it translates the high level concept from the conceptual data model, that is CDM, into more detailed and structured format that can be implemented in a specific data management system. As I said, it can be anything, right? So database, it can be Oracle, SQL, MySQL, right? Or it might be like any NoSQL database also, right? I mean, if you take the recent implementations of the NoSQLs, right? And so LDMs focus on defining the logical structure of the database without considering the physical storage. So again, so there is a thin gap between the LDMs and physical data model, right? So here we already started thinking about the structured format that can be implemented in a specific database. However, we are not worried much about the physical storage aspects. So what is the physically to store the data into the database? What are the structure? What are the DDLs, DMLs, DQLs? What are the indexes that's needed? So that's we are not at all discussing in this LDMs, right? And so if you take LDMs in detail, we want to understand. So translating conceptual model, as we saw, the primary purpose of LDM is to translate the conceptual model into a structured format that can be implemented in database. So it refines the high level entity attributes and relationship defined in the conceptual models. So into a table column constraints. Basically, if you see in the conceptual data model, we were calling like tables as a entities, right? And attribute the columns as attributes and relationships as a relationships. But here when it comes to conceptual data model, so what happens is basically whatever you are calling as a entity, right? So that we started calling as a table here, and whatever we are calling as a attributes, so that we started calling as a columns, and relationships we started calling as a constraints here, right? So that's the difference. And so that is where we started thinking about converting these CDMs to LDMs, LDMs data model, right? And the next is important is the normalization, which is very important when it comes to any database or designing, right? So LDMs often involves normalization. This is the process which usually takes in the LDM phase, normalization, and which is the process of organizing the data into database to reduce the dependencies. This ensures the data integrity and improves the database performance. Suppose, say for example, right? So you have a student table or entity, right? So which is having a student name, department, like which department he belongs to, and what is his date of birth and all those things, right? So suppose like there is no, I want to divide this student table into maybe department, I want to segregate into a separate sub table. So I will take this out, the department column from here, and I'll create a new department table here, right? And with the department ID and department name, so I will have the relationship student belong to department. I can have that relationship here, but I am normalizing the particular table here. So I'm splitting one table into multiple tables. So that's called normalization. So you can normalize to any extent that you want, right? So to improve the performance, to organize, to make it more organized. So that is the normalization, and there are a lot of normalization form. First normalization, second normalization, and so third normalization forms. There are a lot of normalization forms that I don't want to go in detail, but yeah, so you can read through that. And so the next is the relational structure. The logical data model are commonly represented using relational structure where entity becomes tables, attribute becomes columns, and relationship becomes the foreign key constraints. That is what we were discussing here, right? Yeah. And the key elements is again here because we converted entities to tables, so now we are talking about tables, columns, primary keys, and foreign keys instead of entity attributes and relationships. Okay. And let's take an example of logical. For example, we'll take a library management system to understand the logical data model. Okay, so in the library data model, data management system, so you might think there might be entities like student, course, instructor, and department, right? So, and each again, each student, each entities or tables will have their own kind of attributes. But here, important thing is we have already made these as a primary key, whichever the ID columns, right? We have made it as a primary key. If you compare in the conceptual model, we have not identified any primary keys. But when we come to logical data model, it makes sense to create a primary keys to uniquely identify the each tables, each rows in the tables. And moving on, so this is already we have seen, right? So this is a structure we have seen in the conceptual data model. So in the conceptual model, entity student was called as an entity, but note that we are already calling this as a table now. Student is a table, instructor is a table, course is a table, department is a table, and all these attributes, because we are in logical model, these becomes already has become the columns, right? And relationships will become what? Here we already converted the relationships into, so the relationships will become the constraints, right? So this is the that we will see here how they are getting converted into constraint. So this is a relationship, right? So and we are defining here each particular ID columns, right? So at least one primary key should be there to uniquely identify a row, right? So that is what we are making as a primary key here. That is the first step when you're talking about logical data model. And the next step is you need to convert these relationships into constraints, right? That means the primary key and foreign key relationships. So that is where you see enroll by is become enroll table here, and the next is taught by will become a teach table here, and belongs to is also becoming a table here. And so as you can see, enroll table is making the relationship between student ID and course ID here. That means they are logically getting connected here, right? And similarly, like this table is connecting the course ID and instructor ID. And here, this particular table belongs to instructor. This is connecting instructor ID and department ID. So using these tables that are already becoming constraint tables here, right? So finally, we'll go to the physical data model and understand what exactly it means. A physical data model, which is a PDM, is a detailed representation of the database design, right? So it's a detailed representation of database design. So that specify how data will be stored, accessed, and organized within a specific database. So we are started thinking here how it will be stored. That means like we are thinking about the creation of the tables, we are thinking about join when we are querying the table, how we need to get the data, whether we need to get the data in a faster way. So to get the particular data we need to join with any other tables. So all these things we need to consider here when you are defining a physical data model, right? So that's, and it takes the logical data model, that is the input from the previous step, LDM, right, as an input, and defines the actual implementation details including data type, indexing, partitioning, and optimizations for performance. And PDMs provides the blueprint for building and maintaining the physical database schema. So this is a blueprint, right, for building the physical database schema. That means you create a schema, you have a tables in that, you have a views, stored procedures, and indexes, like creation of tables using DDLs, manipulation queries, DMLs. So all these things need to be considered here, right? And so physical data model, when you're talking about it, it's definitely is a translation from the logical data model. The primary purpose of physical data model is to translate the logical model, obviously, into the structure that can be implemented within the specific database. It involves converting the tables, columns, and relationship defined in the logical data model into database objects such as tables, indexes, and constraints. And the next, if you see database specific implementations, so PDMs are tailored to a specific DBMS platform. Example, it might be MySQL, PostgreSQL, Oracle, SQL Server, etc. Right? And taking into account the feature and capabilities of that system. And different DBMS may have different data types, different indexing mechanism, different storage options, right? And different scalability options and all those things, right? And so we need to consider all those aspects. And storage optimization, PDMs addresses storage optimization concerns such as data partitioning, clustering, indexing to improve the data retrieval performance and minimize the um, storage space requirement, and also think about the cost for the storage, right? And what are the key elements, right? Definitely the key elements will be tables, indexes, constraints, and partitions. So indexes, you already might know if you're working in database systems. It is nothing but are created to optimize the data retrieval by providing fast access to the path specific to data subsets. They can be defined one or more columns to speed up the query and enforce the uniqueness constraints. And the constraints are nothing but they are ensures data integrity by enforcing the rules and conditions on the data stored in the databases. Commonly, constraints include primary key, foreign key relationships, and unique constraints or null checks or check particular constraints like not null and all, right? So the partitioning is again partitioning involves dividing the large table, right? So usually partitioning is applied on the large table because so on the small table, there is no need of partitioning because it's already small, so there is no need to multiple create a chunk of the table again. So, but when it comes to the large or huge tables, huge volume of data, so indexes are necessary, and or indexes into smaller, more manageable partitions based on specific criteria, maybe like range, list, hash. Okay, so there are different criteria for partitioning, and partitioning can improve the query performance and facilitate data management takes such as a backup or archival. So these, see, as you see, like indexes, constraints, and partitioning, especially indexing and partitioning, right? So there is no hard and fast rule that you need to create a particular column you need to use for indexing. So it depends on how much volume of the data and how which column you are using in your query when you are reading the data from the database. So if you are using two columns and those two columns are most frequently used in all the queries that you are using, so those might be the case where you need to consider that columns to make a indexes, right? So and unnecessary indexes might cause other different problems. So it's important to understand the why you are making an index, why you are making a partitioning, and whether it is really necessary, right? So that is also important. Okay, and when you see what exactly physical data model looks like, and again considering library management system, so it starts with the DDLs, right? So what exactly the each table create table looks like. So suppose because we are already in PDM stage, which is the final stage, we need to start creating the tables in the database system physically, right? So here we need to have all these create table statements. Okay, so or the create table is one example. You might have views, you might have stored procedures, you might have indexes, partitioning, all those DDLs, right? So you can create all those DDLs, and as you see here, you need to define the constraint, whether it's a primary key constraint and foreign key constraints. You need to define whether it is a not null, right? Suppose this name is not null, right? So you can define a not null constraint here, right? And all those constraints, indexes, primary key, and what is the length, okay? And whether it's date of birth is a date or date time, and varchar of 100 or 200, what is the length of it? So all these things will be considered here in the physical data model, okay? And finally, like as you said, like indexes, constraint, and partition that we have discussed. So these are very key aspects that need to be considered in the physical data model. And finally, let us see the summary of it, right? So CDM, LDM, and PDM, conceptual data model, logical data model, and physical data model. So what exactly the difference is when you look at a bigger picture of it and in one page, right? So we can consider the level of abstraction. So this is definitely CDM is the highest level of abstraction and PDM is a low level of abstraction. So here it focuses on a business requirements and concepts without considering the implementation details, right? And LDM is a high level concept from the CDM into more detailed and structured format, focusing on how data will be organized and accessed. But here it is more about storing, accessing, and organizing within the specific database. So that is a level of abstraction. And coming to the purpose, so definitely there should be different purpose, right? So, and the purpose here for the CDM is to capture essential entities, attributes, and relationship within the organization domain, providing a foundation for understanding the business domain. So here we are not at all talking about the data. Here we are just understanding the requirement, understanding the business domain, right? And all those things, okay? And how exactly the business dynamics is, right? And but when you come to LDM, specifics specifies the logical structure of the database, including tables, columns, relationship, and constraint without considering the specific implementation. So here it is, we are not talking about implementation. But when it go to physical data model, we are talking about the implementation. As we saw, we'll consider indexing, partition, data type, optimization of the database, etc. Okay. And representation. So how do you represent the CDM? What is the output of a CDM? How that it looks like? CDM is usually entity relationship diagram, ERDs, right? And LDMs are usually a relationship model. Again, it might be a ERDs, okay, or it might be UMLs diagrams. UMLs is unified modeling language, and it depicts tables, columns, and relationship between them. And PDM represents using database specific tools script, as we were thinking about DDLs, right? Create table script, create views, create partitions, create stored procedures, what are the queries, right? So those are scripts, so those will come into the PDMs of it. So focus is like in when you talk about CDM, what data should be stored in the database and how entities are related to each other without specifying how data will be stored or accessed. So here in LDM, the focus is defining the logical structure of the database, addressing the data integrity, normalization, and relation aspects. And when you talk about physical data model, the focus is more of translating the LDM to into physical database objects, right? And addressing storage optimization, indexing strategy, performance, etc. So hope this detailed video about CDM, LDM, and PDM with examples was helpful. And thanks for watching.